This is the next lesson in Nat 5 trig graphs. So you should have already looked at phase angle trig graphs that move horizontally left or right. We are now looking at moving the trig graphs vertically up or down. And just like in the last lesson with phase angle, you were told to think of them in terms of the quadratics in the same way. If there's a number inside the bracket, it moves the graph left or right. Well, this is similar. If there's a number at the end, it basically is going to move the graph up or down. So we'll read through these notes at the start. So we should now be familiar with our sine and cosine graphs and understand what these letters A, B and C correlate to. Or A and B we've dealt with already. A being the amplitude, which affects the maximum and minimum values, how stretched it is. B being the number of waves in 360, and now we're looking at a plus C, which is, as it states here, a vertical shift. So it's just a number that's added or subtracted at the end. Okay, and when we have a tangent graph, as we've discussed previously, the amplitude is infinite. It's impossible to define. So all you have there is the number of waves in 180 degrees for your tangent graph, and then the tangent graph still can be shifted vertically up or down. But we will, as is commonly done, we will focus on just sine and cosine during this exercise. So these three graphs that are in front of you is just to basically give you an understanding of the difference between A, B and C. So if you can see, each one of them has a 2. The first one has a 2 in the place of the A, the second one has a 2 in place of the B, and the third one has a 2 in place of the C. So the A affects the amplitude, which means that this is the normal sine x graph. It just goes up to a maximum of 2 and down to a minimum of -2. The second one is sine 2 of x, which means that the maximum is just 1 and -1, but it just means there's twice as many waves in 360. So that's how you see this repeated wave twice in the range of 0 to 360. And the last one is sine x, which means usually a maximum of 1 and a minimum of -1, and it's just one wave in 360, but the difference in numbers here is because this +2 shifts the whole graph up by 2 places. So rather than going up to 1, it's now going up to 3, and rather than having a minimum of -1, add 2 as a minimum of 1. So it's a sine x graph just shifted vertically up 2 places. Okay, so as it states underneath these three graphs, to find the equation of these graphs, we basically are kind of following these bullet points. So it will almost always be just a sine or a cosine graph. So we have to figure out, is it a sine graph, is it a cosine graph? Where's the starting point? Where is it at 0 in the x-axis? That is usually how you differentiate between these two. How many waves are there in 360? That tells us the value of B. What is the amplitude, i.e. half the difference between the maximum and min, and it's important we think of it as half the distance between max and minimum, rather than just what number it goes up to as being the value of A, because what we're going to see today is that number it goes up to is no longer the same number because it's been moved up or down. And compare the y-intercept to where it should be to tell us how much it's going up or down. Okay, and we can use the maximum and minimum values for that as well. So the first two examples, this is example 6. We have the graph of y equals 3 sine 2x plus c. So let's have a look at this graph. Now sine 2x, that 2 means that there's 2 waves in 360, and we can see that there are 2 sine waves. Okay. Now 3 means the amplitude of 3 means it's a distance of 6. And we can see there's a distance of 6 between 4 and -2. Now, in order to figure out what's happened to this, there's 2 options. You can look at where does the sine graph usually start, which would usually start at 0. It's now starting at a y-intercept of 1. So it's fairly obvious from that it's just been moved up 1 place. Or you can think about the maximum and minimum values to do with the 3. So if it was 3 sine x, it would usually go up to 3 as a maximum. It's now going up to 4. It would usually go down to -3. It's now going down to only -2. So hope it's obvious to see that we have been shifted up by 1 place. Therefore, the value of c is just +1. Okay, so that is the graph of y equals 3 sine 2x plus 1. Okay, let's try the next one. So this time we're told it's a cosine wave. We're told that the amplitude is 2, meaning there should be a distance of 4 between the top and bottom, which there is. And we're told it's 3x, so there's 3 lots of these cosine waves in 360, which we can see that clearly. Okay. Now, what I like to think of is, where would this cosine usually start? Well, if it's 2 cosine x, it would usually start at its maximum of 2, which would be, up here somewhere. It's not starting at 2 though, it's starting at -3, which is a distance of 5. So that must mean that the whole graph has been shifted down by 5 places. Therefore, the value of c must be -5. And we can check that in terms of the maximum and minimum values. The maximum would be 2, the maximum is now -3. The minimum would be -2, and the minimum is now -7, which is a distance of -5 as well. So c is, in this case, -5. The graph has been shifted down by 5 places. And the equation of the graph, you don't actually really need to write the equation, but I like to just write it as well, is 2 cosine 3x minus 5. Okay, hopefully that makes sense to see how it's been shifted up or down. We'll try 2 more. So this time we are given the graph of a sine 2x plus c. So it's not just plus c we're trying to work out here, it's also the value of a. So the only number we're given is the 2 in front of the x, which means there's 2 sine waves in 360, which we can see that there is. Right, okay, so in order to find the value of a, remember the amplitude a is half of the distance between max and min. And I'm just going to write this here. Okay, so half of the distance between the maximum and min. So what is the maximum? So that is a maximum of 5, 6, 7. The minimum is at -1, -2, -3. So the distance between 7 and -3, that's a distance of 10. So that means that the amplitude A is therefore going to be half of 10. So A has a value of 5. I'll just extend this page a little bit here. Okay, so we've got our value of A. We know it's 5 sine 2x, but the plus c must mean that it's been shifted up or down something. So we've got y equals 5 sine 2x. Okay, so if we had 5 sine, that would mean that the graph would usually have a maximum of 5. Well, we can see that the graph has now a maximum of 7. Therefore, the whole graph must have been shifted up by 2 places. So let's just check that with the minimum as well. If it was 5 sine 2x, it would have a minimum of -5. It's now got a minimum of -3. So that confirms it, that it's been shifted up 2 places. So c, therefore, has to be a value of +2. So the equation of this graph is y equals 5 sine 2x plus 2. All right, so we'll do the last one, and hopefully this is making sense okay. We're given this time, we're given the amplitude of 4 cosine bx plus c. So we need to figure out how many waves there are in 360. We need to figure out where the graph has been shifted up or down. Now, to get the number of waves in 360, in this case, it's probably easier in that we can just really trace it with our finger and just count them. So it starts at 0 at its maximum, cosine goes down to the bottom, and that's 1 full wave just before the 150. We go again, that's 2 full waves, and then again there's 3 full waves there. So 3 waves, therefore b equals 3. It's actually more straightforward than the amplitude even. Right, so now we just need to work out where this graph has moved up or down. So this is the graph of 4 cosine 3x and then something, plus or minus something. Well, 4 cosine 3x would usually start at 4 and go down to -4. This one is starting at -1 and it's going down to -6, -7, -8, -9. So starting at 4 going down to -1, that's a distance of 5, that's like -5, and then it would usually have a minimum of -4. It now has it minimum of -9, so that's a distance of 5 as well. So it's been shifted down 5 places, therefore c equals -5 this time, because it's been shifted down 5 places. So this is therefore the graph of y equals 4 cosine 3x, take away 5. Okay, so just remember when you're doing these questions, if you're looking for the number of waves in 360, that's pretty easy to do first, and you need to be careful if you're not given the amplitude and you're not given the value of c. If you try and work out how much it's been shifted up or down before working out the amplitude, you're not going to be able to get it correct. So always figure out what is that value of a first, half the distance between the maximum and min, where should that go up or down to, so then what's changed in the vertical shift. Okay, so remember amplitude first, then find the value of c.